The acceptable voltage range for 277/480 volts feet is plus or minus 5% of the nominal voltage. This means the minimum acceptable voltage is 263.15 volts for a 277 volt system and 456 volts for a 480 volt system. The maximum acceptable voltage is 290.85 volts for a 277 volt system and 504 volts for a 480 volt system. A 290/505 volts feed exceeds the maximum acceptable voltage range. This can have several negative impacts on electronic ballasts. Firstly, overheating of ballast components can occur. Secondly, the ballast life expectancy can be reduced. Thirdly, the ballast and or lighting fixtures may fail. Therefore, a 290/505 volts feed is considered too high and should not be used for electronic ballasts. If a 277/480 volts feed exceeds the acceptable range, several steps can be taken. 1. Contact the power company to report the issue. 2. Install voltage regulators to reduce the voltage to an acceptable level. 3. Use voltage-tolerant electronic ballasts that are rated for higher voltages. Voltage regulators are devices that maintain a constant output voltage, regardless of variations in the input voltage. They are commonly used to protect sensitive electronic equipment from damage caused by voltage fluctuations. Voltage-tolerant electronic ballasts are designed to operate within a wider voltage range than standard ballasts. This makes them a good option for applications where the voltage supply is not stable. When selecting a voltage regulator, it is important to choose one that is appropriately sized for the load it will be powering. The regulator should also be compatible with the type of electronic ballast being used. When selecting voltage-tolerant electronic ballasts, it is important to choose ballasts that are rated for the maximum voltage that is expected to be present in the system. The ballast should also be compatible with the type of lighting fixtures being used. Proper voltage management is essential for ensuring the safe and reliable operation of electrical equipment. By understanding the acceptable voltage range for 277/480 volts feed and taking appropriate steps to mitigate voltage fluctuations, it is possible to prevent damage to electronic ballasts and other sensitive equipment. Electronic ballasts are a crucial component of many lighting systems, providing the necessary voltage and current to operate fluorescent and LED lamps. They are more energy efficient than traditional magnetic ballasts and offer features such as dimming and programmed start. However, electronic ballasts are also more sensitive to voltage fluctuations. Operating an electronic ballast outside of its rated voltage range can lead to premature failure, reduced light output, and increased energy consumption. Therefore, it is essential to ensure that the voltage supplied to electronic ballasts is within the acceptable range. The acceptable voltage range for electronic ballasts is typically specified by the manufacturer. This information can be found in the product documentation or on the ballast itself. In general, electronic ballasts are designed to operate within a voltage range of plus or minus 10% of the nominal voltage. However, some ballasts may have a narrower or wider voltage range. It is important to consult the manufacturer's specifications to determine the acceptable voltage range for a particular ballast. In addition to voltage fluctuations, electronic ballasts can also be affected by other power quality issues such as harmonics and transients. Harmonics are distortions of the sinusoidal voltage waveform that can cause overheating and damage to electrical equipment. Transients are sudden spikes in voltage that can also damage electronic components. To protect electronic ballasts from power quality issues, it is important to use surge protectors and filters. Surge protectors are devices that protect against transient voltage spikes. Filters are devices that reduce harmonics and other noise in the electrical system. Proper grounding is also essential for protecting electronic ballasts from power quality issues. Grounding provides a low impedance path for fault currents to flow back to the source, which helps to prevent electrical shock and equipment damage. The National Electrical Code, or NEC, provides detailed requirements for grounding electrical systems. It is important to consult the NEC and follow its requirements when installing and maintaining electrical systems that use electronic ballasts. The NEC also provides requirements for overcurrent protection, which is the use of fuses or circuit breakers to protect electrical circuits from overloads and short circuits. Overcurrent protection is essential for preventing fires and electrical shock. It is important to select overcurrent protection devices that are appropriately sized for the circuits they are protecting. The NEC contains tables that provide guidance on selecting the correct size of overcurrent protection devices. In addition to the NEC, other standards and regulations may also apply to the installation and use of electronic ballasts. These standards and regulations may be issued by state and local governments, as well as industry organizations such as the Illuminating Engineering Society, or WISE. It is important to be aware of and comply with all applicable standards and regulations. Regular maintenance is essential for ensuring the safe and reliable operation of electronic ballasts. Maintenance tasks include inspecting the ballasts for signs of damage, cleaning the ballasts to remove dust and debris, and testing the ballasts to ensure that they are operating properly. It is also important to replace ballasts that are nearing the end of their life expectancy. The life expectancy of an electronic ballast is typically specified by the manufacturer. By following these tips, it is possible to ensure that electronic ballasts operate safely and reliably for many years. It is also important to consider the environmental impact of electronic ballasts. Electronic ballasts contain electronic components that can be harmful to the environment if they are not disposed of properly. Therefore, it is important to recycle electronic ballasts at the end of their life. Many communities have recycling programs for electronic waste. Contact the local recycling center for more information. By recycling electronic ballasts, it is possible to reduce the amount of waste that goes to landfills and protect the environment. The design and installation of electrical systems require specialized knowledge and skills. It is important to consult with a qualified electrician when designing and installing electrical systems that use electronic ballasts. A qualified electrician can ensure that the electrical system is installed in accordance with all applicable codes and regulations. A qualified electrician can also help to select the appropriate electronic ballasts and other electrical components for the application. Working with electricity can be dangerous. It is important to take precautions to avoid electrical shock and other injuries. Always de-energize electrical circuits before working on them. Use insulated tools and wear appropriate personal protective equipment such as safety glasses and gloves. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. In addition to the technical aspects of electronic ballasts, it is also important to consider the aesthetic aspects of lighting. Lighting can have a significant impact on the appearance and feel of a space. It is important to select lighting fixtures and electronic ballasts that provide the desired level of illumination and color rendering. The Illuminating Engineering Society, or WISE, provides guidance on lighting design. The IES publishes recommended practices for lighting various types of spaces. It is important to consult the IES recommended practices when designing lighting systems. Lighting controls can be used to adjust the level of illumination in a space. Lighting controls can be manual or automatic. Manual lighting controls allow occupants to adjust the lighting to their individual preferences. Automatic lighting controls use sensors to detect occupancy and adjust the lighting accordingly. Lighting controls can save energy and improve the comfort of occupants. Daylight harvesting is a technique that uses natural daylight to illuminate a space. Daylight harvesting can reduce the need for artificial lighting and save energy. Daylight harvesting systems typically use sensors to detect the amount of daylight available and adjust the artificial lighting accordingly. LED lighting is becoming increasingly popular due to its energy efficiency and long life. LED lighting uses semiconductor devices to produce light. LED lighting is more energy efficient than traditional incandescent and fluorescent lighting. LED lighting also has a longer life than traditional lighting. LED lighting is available in a variety of colors and styles. Smart lighting systems use sensors and software to control lighting. Smart lighting systems can be used to optimize energy efficiency, improve security, and enhance the comfort of occupants. Smart lighting systems can be controlled remotely using a smartphone or tablet. Emergency lighting is lighting that is designed to provide illumination in the event of a power outage. Emergency lighting is required in many commercial and industrial buildings. Emergency lighting systems typically use battery backup to provide power during a power outage. Exit signs are signs that indicate the location of exits in a building. Exit signs are required in many commercial and industrial buildings. Exit signs must be illuminated and clearly visible. Explosion-proof lighting is lighting that is designed to be used in hazardous locations where there is a risk of explosion. Explosion-proof lighting is typically used in chemical plants, refineries, and other industrial facilities. Marine lighting is lighting that is designed to be used in marine environments. Marine lighting is typically used on ships, boats, and docks. Landscape lighting is lighting that is designed to illuminate outdoor areas such as gardens, lawns, and walkways. Landscape lighting can be used to enhance the beauty of a property and improve security. Security lighting is lighting that is designed to deter crime. Security lighting is typically used to illuminate parking lots, walkways, and other areas that are vulnerable to crime. Sports lighting is lighting that is designed to illuminate sports fields and arenas. Sports lighting must provide adequate illumination for players and spectators. Stage lighting is lighting that is designed to illuminate stages for theatrical performances. Stage lighting is used to create different moods and effects. The information provided is for general guidance only. It is important to consult with a qualified electrician or lighting designer for specific recommendations. Also, always consult and adhere to the local and national electrical codes and regulations.